Welcome to our chapter on counting. So this chapter is going to be more interesting than what it sounds, but really what it boils down to is counting. Now the fancy word for counting, and this is oftentimes the word that's used, is combinatorics. But really what combinatorics boils down to is counting. So there's two main things that we're going to talk about in this chapter. And again, the first one is kind of the simple one of just counting. Basically, how many ways or how many things or how many times or just how many somethings, right? Can we do something? And the second thing is going to be enumerating. And that's going to be specifically making a list and specifically a systematic list. How can we systematically list a bunch of ideas or objects? And these are going to be a little bit more complicated than they initially appear. So some of the questions, we're not going to answer these now, but some of the questions that combinatorics really addresses are these ones. How many different quarter schedules would be possible if you know you wanted to enroll and have 15 credits? So it'd be a ton, right? There are so many different options. And we're going to talk about how we can answer that question. We could also ask how many possible passwords are there if your password is 6 to 10 alphanumeric characters. A much simpler question to answer, I think, and we will actually address that in the next video. Yep, not this video. And again, a more complicated question is how likely would it be for a network buffer to overflow if we know its packets are addressed to 3 different definitions? Is another concept we're going to talk about in this chapter. Basically, and it ties in with a lot of probability as well, just these concepts of it's important to know how many different ways something can happen, because then, of course, in probability, if they all have the same likelihood, then we can just divide and find the probability. If there's different probabilities, we can work with that too. And just knowing how many ways something can be done is useful in general. Okay, so we're going to start off with the fundamental theorem of fundamental theorem of combinatorics. I'm still a little sick. My brain's not at 100%. But before we do that, I do want to quickly mention that not one of these is not always easier than the other. Sometimes counting is going to be easier. Sometimes enumerating is going to be easier. It really kind of depends on the situation. All right, let's get into the fundamental theorem of counting. If you can divide a task into k parts, or divide a series of choices into k parts, however you want to determine that, each with n sub I, that's supposed to be a subscript, choices, then there's some number of ways of doing that. How many ways are there to do it? Pi, that's a capital pi right there, a big capital pi. All right, October is trying to climb the green screen. The curtain has been lifted, well, in this case, fallen. But anyway, how many ways are there to do it? Pi of ni, where I goes from 1 to k. Now, you may not have seen this notation before, but it's similar to summation notation if you've seen that, right? If you've seen like the sum of ni thing, if you've seen that, this is very similar. But instead of sum, this is product. So really what this means, and I'll write this out because you may not have seen this. This is just, well, if there's n1 ways of doing the first thing, and n2 ways of doing the second thing, and n3 ways of doing the third thing, you just multiply all these together. All right, and that's a bunch of dots until we get to the last one of n sub k. And I think this is pretty intuitive for a lot of people. We're going to see that in action with this example. How many 4-digit pins are possible? Well, we'll just approach this systematically. How many choices are there for the first digit? How many choices are there for the second digit, third digit, fourth digit? We'll multiply them all together using the fundamental theorem of counting. I've taught too many calculus classes and I keep wanting to say fundamental theorem of calculus, but this is different. There's also fundamental theorems of algebra, fundamental theorem of linear algebra, fundamental theorem of calculus is another big one. There's a lot of fundamental theorems in math, but this is the fundamental theorem of counting, not calculus, although both FTC abbreviations. So again, we just say, well, the first digit can be any number between 0 and 9. The second digit can be any number between 0 and 9. The third digit, oh. The fourth digit, oh. It's just 10 to the fourth power, which is 1, 2, 3, 4 zeros, 10,000 ways. And that, in its essence, is what combinatorics is all about, just counting. In reality, there are some nasty, nasty combinatorics problems out there. I remember the first quarter of my grad school, I took a graduate level combinatorics class, and I dropped it within a week because I didn't even know what they were talking about. So it can get very, very gnarly. We're not going to get very gnarly in this chapter. Just kind of introduce some things. Let me know if you have questions. We'll do some more examples in the next video.